Good afternoon, everyone. Today we'll be talking about solar power. We'll be going over three parts. The first being the science behind solar panels, the second being the history of solar power, and the third being the potential of solar power. The first part, the science behind solar panels. What is solar power? Solar power, or known as solar electricity, is the conversion of sunlight into energy. And how do the panels work? The solar panels mainly use this photovoltaic effect to convert light into an electric current, or they can indirectly use concentrated solar power.
What's the photovoltaic effect? Photovoltaic effect is the generation of voltage and electric currents in a material upon exposure to light. The photovoltaic effect is closely related to the photoelectric effect. The main distinction is that the term photoelectric effect is now usually used when the electron is ejected out of the material. And photovoltaic effect is used when the excited charge carrier is still contained within the material.
This is the formation of a solar cell, and it is comprised with a p-type material and an n-type material, where the p stands for positive and the n stands for negative. Between the two layers forms a p-n junction, and the depletion zone lies right in the p-n junction, which is formed of neutral atoms. When the sunlight hits the solar cell, it penetrates through the n-type layer and hits the depletion zone in the p-n junction. And the sunlight separates the electrons from the neutral atoms, and after the electrons flows to the n-type material, the current forms. You will be amazed to see how these PV cells are interconnected. They are connected to the next cell, the backside of the next cell, through copper strips. And here, it forms a series connection. When this series connected cells are attached to other series connected cells, you get the solar panel.
Part 2, the history of solar power. The early development of solar technology started in the 1860s. Due to an expectation that clothes would soon become scarce. However, the oil and energy crisis in the 1970s caused a reorganization of energy policies around the world and brought more attention to developing solar technologies. In the mid-1990s, rooftop solar began to accelerate due to supply issues with common fuels, followed by global warming concerns. Fourthly, due to recent global energy crisis, utility scale solar was still the cheapest energy sources due to the rising cost of other energy sources. However, fossil fuel subsidies have slowed the growth of solar generation capacity, causing it to still remain the most common power energy.
Part 3, potential of solar power. Why do we even choose solar power in the first place? There are three main reasons. The first being sustainability. One solar panel can last for up to 2 decades. The second being expenses. As technology advances, the cost of solar panels have greatly reduced. The third being stability. Solar electricity will not be affected by geopolitics, unlike oil and gas. A great example of this would be Russia. Is solar power correct? Unfortunately, no. energy has to be used right away, or it could be stored in large batteries. Second, the more electricity you need to produce, the more solar panels you need to produce it, which uses a lot of space. Third, although the solar energy can be collected during rainy and cloudy days, the efficiency of the solar system drops. Even though solar power has its own disadvantages, but it doesn't mean we should give up on our environment.
This is the end of our presentation. We thank you all